Hi, have you tried this? Oh, I believe you did. There is nothing special. It's the same. Now we are conditioned on smokers, and among smokers, we are looking for the probability of not having a cholesterol problem, which is 9.43%. So you look at only the first column. Only the first column. These guys are not relevant. So look at these two numbers and calculate the how much the proportion of this guy. So mathematically, you have this result. The answer is 19.89. And the reason why I let you do this is because I would like to compare this with this. Remember, the probability of high cholesterol among smokers was 80.11%. Do you see the relationship? And so the relationship between them is that they have the same denominators because these two guys have the same condition. Among smokers, high cholesterol 37% and not having a high cholesterol 9.43%. So there's some, if you think about these two conditional probabilities, there's some must be always 100%. The point here is the conditions are the same. They have the same condition, but the event of interest are complements to each other. It is called complement rule for conditional probability. So it's a probability of H occurring given S, probability of H not occurring given S. So as long as the condition is the same, under the same condition, anyhow in the end it's either a H happens or not. So the sum of these two probabilities must be 100% because always H happens or not happens. There are only two options, and that's the idea. So these two are complements under the same condition. H and H complement become the complementary relationship. So in the end, we have complement rule. What the point here is, the complement, when you take complement, sum has to be 100%, then the complement sign is put only on the main event. So condition should not change. That is the point of this complement rule. Right? So when I ask you this question, you do not need to calculate from this table because we already know this value. If you have this value, this number, then this automatically implies this probability equals to 100% minus the previous number. So that is just another way to approach to this question. It's up to you. It's a simple question, but I want you to show you this formula, this rule, and also it is a good example to understand the role of the condition. The fixing the condition is very important in many analysis. Okay, we had two examples, and I will show you another example. It's a fake example. It's not real. Now, the research question we would like to study is, does paying high tuition pay off later? So it's a little bit interesting, very interesting question. And I define events in this way. T stands for tuition is high. So you graduated from a high tuition university. And say S stands for you are making a high salary. So S for salary, T for tuition. So I would like to study. If you graduate from a high tuition school, is there any better chance of making a higher salary or not? So you you I believe you understand what we have to compare in casual language. Now formulate that comparison using the notation again. So the same question as before, as in the previous one, but now so try again. Uh, you now have to understand how to solve this problem. Do this.